Hello, so this is the sixth video of chapter 6, and it's on balancing equation with odd number of atoms. And that's the last concept check here, concept check 6. So the text says, solid calcium nitrate decomposes to solid calcium oxide, nitrogen dioxide gas, and oxygen gas. So let's write the formula of the reactant and the products. So calcium nitrate is the reactant and it decomposes, which means it's the only reactant. Calcium is the 2+ ion Ca2+. Nitrate is the polyatomic ion NO3 -1. So we have calcium with 2 positive charges, nitrate with 1 negative charge. So we will need 2 nitrate per calcium. So it's going to be Ca and then NO3 2 times. NO3 is the nitrate, and we need 2 nitrates per calcium to cancel the charges on the calcium. That's solid, so S for solid. And then we have the arrow because it decomposes. So we have only this reactant and it decomposes into several products. First, solid calcium oxide. Calcium, again, is the 2+ ion, Ca2+. Oxide is the oxygen when it's an ion, and it's O -2. So 2 negative charges on the oxide, 2 positive charges on the calcium. So one of each atom or one of each ion will make this a neutral formula. So calcium oxide is just CaO and S for solid. Nitrogen dioxide, that's a molecular compound made of nitrogen and then oxygen. The di here tells you there is 2 oxygen for 1 nitrogen. So it's going to be NO2 gas. And then oxygen gas is the oxygen you find in the air, and that's O2, and that's a gas. So we have now our skeletal equation. So let's count the number of atoms of each kind on both sides of the arrow. On the left, we have 1 calcium, and on the right, 1 calcium in CaO. On the left, we have 2 nitrogen because we have 2 nitrate per calcium. And so the 2 applies to the nitrate. And we have then 2 nitrogen atoms on the left and only 1 on the right from the NO2. Oxygen, we have 2 times 3 because we have 2 nitrate and each nitrate has 3 oxygen. So 3 times 2, it's going to be 6 oxygen on the left. And on the right, we have 1 from the CaO plus 2 from the NO2, that's 3, plus 2 more from O2, that's 5. So we have 5 oxygen on the right. So the calciums are balanced, so let's balance the nitrogen. We have 2 nitrogen on the left, let's make it 2 on the right. And for this, we will want to make a coefficient of 2 in front of NO2, because that's the molecule that has the nitrogen. So then now we have 2 nitrogens on the right. So that balances the nitrogen, the calcium are still balanced. But the 2 here in front of NO2 changes the number of oxygen. So we need to recount the number of oxygen. And in 2NO2, we have 2 times 2, 4 oxygen, plus 2 in the O2, plus 1 in CaO. So that's 7, 4 plus 3, 7. And we have 6 on the left. But notice how we have O2 on the right side, which means it's oxygen by itself. So let's already try to make it 6 by putting a coefficient that will allow us to make it 6 on the right. We cannot change the 2 in front of NO2, so that's going to be 4 from there, plus 1 from the CaO, that's 5. So to get 6, we need only 1 more oxygen. So let's put 1.5 in front of O2, and this way that will make only 1 more oxygen instead of 2. So this way we have 6 oxygen on the left, 6 oxygen on the right. So it is balanced, right? The calcium are still balanced. nitrogen still balanced, and that 1.5 in front of O2 balances the oxygen. However, we cannot keep coefficients as fractions. So we will need to get rid of that fraction. And to get rid of the fraction, we need to multiply all the coefficient we have now by 2 to get rid of that 1/2, right? If you multiply by 2 times 1/2, it's going to be 1. So let's rewrite the equation now with, twice the number of coefficients. So in front of CaNO3, it's going to be 2. In front of CaO, it's 2. And then 2 times 2, it's going to be 4 in front of NO2. And then 1.5 times 2, it's going to be 1 in front of O2. So that looks like what we have below. So let's make sure it is balanced. So on the left, we have 2 calcium. On the right, 2 calcium. On the left again, we have how many nitrogen? So 2 nitrates, that's 2 nitrogen times 2 CaNO3 times 2. So that's going to be 2 times 2, 4 nitrate, or sorry, 4 nitrogens on the left. And on the right, we have 4 NO2, so that's 4 nitrogen. Oxygen, we have 2 nitrates times 2 times 3 oxygens per nitrate, that's 6 per molecule here. 6 times 2 is going to be 12 on the left, 12 oxygen on the left. On the right, we have 2 in CaO, 2 oxygen, plus 4 times 2, 8 in the NO2. So 2 plus 8 is 10, and then 1 O2, so 2 more oxygen. So that's 12. So we do have the same number of each kind of atom on both sides of the equation, and this is balanced.